This is problem number 3 from the linear programming packet day 1. In this problem, a company makes whole wheat crackers and sesame crackers. They're sold by the box, where each box contains 5 packets of whole wheat crackers and 3 packets of sesame crackers. And they cannot produce more than 150 packets per minute. So from that we can get one constraint for this problem, and that is 5x plus 3y is less than or equal to 150. As we continue reading in the problem, we see that they have to make at least 15 packets of whole wheat crackers a minute, and they have to make at least 20 packets of sesame crackers. And I want you to notice here that there was a typo when this was originally drafted. I believe your copy says boxes right here, and it also says buckets here with the sesame seed crackers. That should be packets. The word box, I think, is confusing with respect to this problem. So that's 2 additional constraints. So I'm going to put the whole wheat crackers in red, so when we draw it on the graph, it'll be easy to distinguish that from the other constraints. So x must be greater than, or equal to 15. And we'll do y in green, and y must be greater than or equal to 20. Let's continue reading the problem. We need our objective function. It says if the profit per box of whole wheat crackers is 10 cents and the profit on the sesame seed crackers is 5 cents, how many boxes of each should be produced to maximize profits? So that's clearly the objective function. So let's go ahead and write that down, and I'm going to use functional notation because it's a function of x and y. And let me make sure I get these numbers correct. So 10 cents is on the whole wheat, which is x. And I'm using a dollar notation. And 5 cents is the profit on the sesame seed. And you could easily write this as 10 cents, so it would be 10x. And 5 cents for the sesame seed is 5x. I'm just choosing to use dollars. It really doesn't matter. Do what you find most convenient. So now we would go on to graph. And if we look at our graph, there's no scaling on it, so we have to determine the scaling. And a convenient way to do that is to look at our linear inequality and find the intercepts, and that will give us a sense of how many boxes we should use per what unit. So I'm going to go ahead, use the intercept method, 0 for x, 0 for y. And when x is 0, y is 50. And when y is 0, x is 30. So I'm going to use 4 boxes for 10 units. So that's 10. So here's 10. 20, 30, and you might want to follow along on your copy. 10 on the x, 20, 30, and I don't need to go beyond 30, I'll just do 40, and this is 0 here. So let's go ahead and graph the linear inequality. So we have an intercept at 0, 50, another intercept at 30, 0, and I'm going to go ahead and draw our line, and it looks something like this. And since it's less than, we're going to be this side of this particular linear inequality. We can go ahead and graph the x inequality. So x has got to be greater than 15. Here's 15 right here. And since it's greater than, we'll be on that side. And y is greater than 20. So that'll be here. And we're going to be on this side. Let me erase that and draw a needle line. let's do this again. So I'm missing the 0 there. The software doesn't want to behave today. And the 15. And then the 20. So the 20 is greater than, the 15 is greater than, but the black line, the 5x plus 3y is less than or equal to 150. That puts our feasible region right in here. It's just a little triangle. So our 3 vertices are here, down here, and this one here. So there are the vertices. So we need to determine those. And the one in the lower left is easy because that's where the 2 single constraints intersect. So that'll be 15, 20. The other 2 we're going to have to substitute in our vertical and horizontal line into the 5x plus 3y is less than or equal to 150 inequality. So let's go ahead and do the x. So we'll have 5, and x is going to be equal to 15 plus 3y equals 150. And 5 times 15 is 75, so that tells us y equals 25. So we will have an ordered pair of 15, 25. And then for the other one, y is 20, so we'll have 5x plus 3 times 20 equals 150. And this says x will be equal to 18. So the other ordered pair will be 18, 20. So we now have our 3 vertices. The next step is to examine the profit at each one of these vertices. So I'm going to go ahead and just do them in order. P of 15, 25 will equal 5 times 15. Oh, excuse me. I'm using the objective function. So it's going to be 0.1 times 15 plus 0.05 times 25, and that will equal 275. Let's do the next one. Let's do 15, 20. So that'll equal 0.1 times 15 plus 0.05 times 20. And that will equal $1.50 plus $2, so that's $2.50. And then finally we'll have P equals, what's the other one? Oh, it's 1820. So that's 0.1 times 18 plus 0.05 times 20, and that will equal 280. So our max is when we produce 18 wheat and we produce 20 sesame. That concludes the video.